Now is to do the two-sum problem from LeetCode. This is the first problem in LeetCode, and we are going to do the efficient way to solve this problem. I already did a video about how to solve it naively in the time complexity of O of n squared. Now we are going to solve it in time complexity of O n, namely linear time. So what is the problem and what should we do and what is the solution? So the problem is what you can see here. We have an array. We are given an array. Here it is here, which is called nums, and we're given a number which is called target. The number corresponds to the sum of two values from the nums array that should be the sum should be the target value. Namely, if I am given this array of nums and this target, I should return the indexes of the values that sum up to the target value, to 9. And I should only use two indexes. Namely, look at here, which two numbers are summed up to 9. Those are 2 and 7. Therefore, I should give as a result the indexes of these two numbers, which is index 0, the first index, and index 1. Now, I can't use the same number in the same place twice, and also I'm guaranteeing that there is exactly one solution, and there is a solution. So now let's move to the other example. Look at this array. I have an array of 3, 2, 4, and I have a target value of 6. So which two numbers that are different from each other, not different from each other, are not in the same place? Namely, I can take 2, 2, 2, or I can take 3 and 3 because this is in the same place. If I had 3 and 3 here, I could take 3 here, 3 here, but 3 in the same place I can't take twice. So which numbers in different places, two numbers sum up to 6, those are 2 and 4, namely indexes 1 and 2. Therefore, the result that I am given back is the two numbers that represent the indexes of the number that should be summed up to the target value. And another example, 3 and 3, target 6, so I can take this one and I can take it again, so I take also this one, so the indexes are 0 and 1. The two values sum up to the target. And this is the solution, the efficacy solution. When we are getting the two-sum function, we are getting the array of numbers nums here, and we are getting the target value, this target value here, and the nums is a list of ints, the target is int, and I need to return a list of int, which is this, which is the indexes of the place in the nums array where the values sum up to the target value. So this is the code. What we are doing here is we are describing a hash table which will have the values and the indexes of what we are going on now, and we will see a video now that will explain how it goes. But the idea is create a hash table, run on the nums array. For each value in the nums array, calculate the complement, which is the target value, minus the num we are at now in the nums array. If the complement is in the hash table we are building, so return the num index and the complement index. This is the result. If the complement is not in the hash table, so add the num we are at now and it index to the hash table. And let's see how it happens, how it goes. So this is what happens. So the two-sum problem with hash table, this is what we are going to do. So we start with an array. Let's take an example of this array with target 23, and this is the code we just look at. So the hash map, this is the num to index map. This is the hash table, starts being empty in the start. So we are starting with for I num in enumerate nums. I goes on the indexes, num goes on the values of the nums array, which is this array. This is our nums array. Now we start with the first value, which is 2, and we are going to calculate the complement. which is the target value, which is 23 in this example, minus the num we are at now. So we will get a complement of 21. So we'll see the complement here. This is 21. Now what we are going to do to check if the complement is in num2 index, which is our hash table. The hash table is empty, so the result is false. So what we are going to do is num2 index insert the value, which is 2, and its index, which is I, to the hash table. And this is what happens, you see. Here it is. Now we are continuing to the next value, which is 7. We are calculating the complement, which is 23 minus 7, which is what you are seeing here, 16. Now we are checking again. Does the complement is in the hash table? And the answer is no. Therefore, we'll insert 7 and its index to the hash table. Now we're going to the next value, which is 11. We are going to calculate the complement value, which is the target minus the 11. Now, does the complement is in the hash table? The answer is no. So again, we insert the 11 and its index 2 to the hash table, and this is what happens. Again, we continue to the next value, which is 15. Now, what is the complement? The complement is 8. Now, does 8 is in the hash table? No, it's not. So we are inserting 15 and its index to the hash table. We continue. We continue to the next value, 1. 1 target minus 1 is 22, so the complement is 22. We're checking, does the complement is in the hash table? The answer is no, so we insert 1 and its index. Now we're going to the next one, which is 8. Target minus 8 is 15. Now, does 15 is in the hash table? The answer is yes, here it is. It came from here. Here it is, we already had 15. Therefore, we have an answer. We have an answer because the complement of A and the target is 15 and it's already in the hash table. So we will get here to be true. So we will return the num2 index of the complement, namely the 3 and the index of the value we are at now, which is 8. So we found a solution using the hash table, and it's 3 and 5. 3 is the 15, 5 is the index of 8. Together, the value is the target. The value is 23. So we return the result, and the result is 3 and 5. So let's look at it again in one shot, how hash table can be used to solve this problem efficaciously. Remember that working on a hash table is very efficacious. So we start with the empty hash table. We're going throughout the array and calculate the complement. We start with 2 and then 23, so the complement is 21. It's not in the hash table, so we insert 2 and its index to the hash table. We are going to the next value, which is 7. We are calculating the complement, which is 23 minus 7, which is 16. 16 is not in the hash table. The complement is not in the hash table. We didn't see the complement yet. So we insert 7 and 1. Next is 11. Target minus 11 is 12. 12 is not in the hash table. So we insert 11 in its index to the hash table. We didn't see the complement. There is no complement to 11. 15. Remember, 15 is part of the answer, but we didn't see it, 8. So because we didn't see, the hash table doesn't have 8, so we insert 15 and its index. Next is 1. The complement is 22. We didn't see this complement in the array until now, so we need to insert 1 and its index 4 to the hash table. And we are going forward, 8. 8 complement with the target is 15. We did see 15 and it's in the hash table. Therefore, we found the complement of 8 in the hash table, so we found the solution. Therefore, we return the indexes of 15 and 8. Okay? So, this is the idea. This is how, using the hash table, we can solve this two-sum problem. So if we look at the time complexity, let's look at the time complexity. Let's just run this solution and see how it works. So we can see it works. So how the time complexity goes. So of course, to define num to index the hash table, it's just of constant. Now to run on all the nums, the array of num is time complexity of n, the length of the nums. Now, now to calculate the complement is just target minus nums, so it's again constant value. To look at the hash table, if complement is in the num2 index, if the complement is in the hash table, namely if we already saw the complement of the complement in the hash table, it's just again 1 because it's time complexity of a constant. Now we are just doing a return. Return is again a constant value. So again the time complexity is O of 1. Now we are doing the num2 index. This is if we didn't see the complement in the hash table, we need to insert the value we are at now on the array and its index. So again, it's O of 1. And if we look on all the complexities and sum them up, what we get is a linear time complexity, which is O of n. Okay, this is it. This is how we use hash table to solve efficaciously the sum problem, the two sum problem. And we'll see it run very smoothly right now. So the idea will be very clear. Calculating the complement, checking does the complement is in the hash table. If it's not, insert the value in its index. Continue like this to the next value 7. Calculate the complement if the complement is not in the hash table, so insert it and its index to the hash table. And continue like this again and again. Now to 11, calculate the complement. Check if the complement is in the hash table, namely if we already saw the complement of 11. We didn't see it, therefore insert the 11 and its index to the hash table. And continue. 15. Did we see the complement of 15, which is 8, until now in the array? The answer is no. Therefore, we need to insert the 15 to the hash table, even though 8 is in the num array. We didn't see it yet. 1, the complement is 22. We didn't see 22. Therefore, insert 1 and its index to the hash table. And this is continuous until we get to 8. Complement of targeted 8 is 15. We did see it's in the hash table. Therefore, we did see the complement of 8, and this is the result. Now we just return the complement index, which is 3, and the index of 8, which is 5, and this is the result. And this is how we used hash table to solve efficaciously the two-sum problem. Thank you very much. If there are any corrections, please correct me. And that's it.